Have you ever wondered, how do we know the age of the universe? After all, we don't have a time machine. No one was there to witness the beginning of everything. Yet scientists confidently state that the universe is about 13.8 billion years old. It sounds like magic, but it's science. In this video, we're diving deep into the methods scientists use to uncover this mystery. The universe's expansion, cosmic radiation, the oldest stars, and much more. If you think the universe is fascinating, get ready to expand your mind even further. For thousands of years, humanity has looked at the night sky for answers. Ancient Greek philosophers, like Aristotle, believed the universe was eternal and unchanging. For centuries, this idea persisted. Even with the rise of modern science, by the early 20th century, many scientists still believed that the universe was static. In other words, that it didn't change over time. In fact, Albert Einstein himself adjusted his equations for general relativity in 1917 to support the idea of a static universe. He introduced a cosmological constant, a sort of anti-gravity force, to balance gravity and prevent the universe from collapsing in on itself. Later, Einstein would call this the biggest mistake of his life. The turning point came in 1929, when astronomer Edwin Hubble made a groundbreaking discovery. He observed that galaxies are moving away from each other, and even more intriguing, the farther away a galaxy is, the faster it moves. This meant that space itself was expanding. This expansion led scientists to an astonishing conclusion. The universe, in the past, was incredibly smaller, denser, and hotter. This initial point became known as the Big Bang. But how can we estimate exactly when this beginning happened? That was the big question scientists began to tackle, and the answers came in surprising ways. Hubble's discovery was just the beginning. The relationship between the distance of galaxies and their velocity is described by Hubble's law. This law is based on a simple but profound concept. If we know how fast something is moving and how far it has traveled, we can calculate how long it's been moving. In the case of the universe, this speed comes from the redshift of light from galaxies. As a galaxy moves away, the light it emits is stretched, shifting to longer, redder wavelengths. By measuring this redshift, scientists can calculate the rate of the universe's expansion, known as the Hubble constant. But the story is more complicated. Recent discoveries have shown that the universe's expansion isn't constant. During the first few billion years, the gravity of galaxies and dark matter slowed the expansion. But about 5 billion years ago, dark energy, a mysterious force that permeates space, began accelerating the process. This shift affects the calculations, but with advanced cosmological models, scientists have been able to adjust for these factors to estimate the age of the universe. Around 380,000 years after the Big Bang, the universe underwent a transformative event, recombination. Before this, it was an opaque plasma where light couldn't travel freely. As the universe expanded and cooled, protons and electrons combined to form neutral atoms, allowing light to escape and spread across space. This ancient light, now stretched and cooled by billions of years of expansion, is the cosmic microwave background, CMB. The CMB is often described as a snapshot of the infant universe. The temperature fluctuations captured in this radiation aren't random. They represent tiny differences in density that would later grow into galaxies, stars, and planets. By studying the size, shape, and distribution of these fluctuations, scientists gain insight into the conditions of the early universe and how it evolved. This radiation isn't just a clue to the universe's age. It's a key to understanding the entire cosmic structure. Discovered accidentally in 1965 by Penzias and Wilson, the CMB is a relic of the early universe. Modern satellites like Planck have mapped tiny temperature fluctuations in this radiation, revealing the universe's density and composition during its infancy. These measurements allow scientists to calculate its age with incredible precision, making the CMB one of the most critical pieces of evidence in determining that the universe is 13.8 billion years old. Stars act as timekeepers for the universe's history, and the oldest among them tell a compelling story. Globular clusters, dense groups of stars orbiting galaxies, contain some of the oldest stars ever observed. By analyzing their light through spectroscopy, scientists determine their chemical composition and, thus, their age. These clusters not only reveal the age of individual stars, but also offer a window into the formation of galaxies. Because globular clusters formed early in the universe's history, they help astronomers understand the conditions that led to the creation of galaxies, including our own Milky Way. Their sheer stability over billions of years makes them invaluable in piecing together the timeline of cosmic events. Older stars contain fewer heavy elements since those elements formed in later generations of stars. One remarkable example is the Methuselah star, estimated to be 13.2 billion years old. Studies of these ancient stars, combined with observations of globular clusters, consistently point to a universe that began around 13.8 billion years ago. In the early universe, pressure waves called baryon acoustic oscillations, BAOs, rippled through the dense plasma, creating patterns that still influence the distribution of galaxies today. These ripples act like a cosmic ruler, helping scientists measure the scale of the universe's expansion over time. What makes BAOs especially important is their connection to dark matter and dark energy. These mysterious components, which make up most of the universe, also left their fingerprints in these early sound waves. By studying how these ripples evolved, scientists refined their models of the universe's composition, including the elusive forces shaping its fate. BAOs are a bridge between the universe's earliest moments and its large-scale structure today. Using massive surveys like the Sloan Digital Sky Survey, astronomers map these patterns in the large-scale structure of galaxies. By comparing these measurements with other data, such as the cosmic microwave background, they confirm the universe's expansion history and its age. BAOs, along with other evidence, strengthen the accuracy of the 13.8 billion year estimate. What makes 13.8 billion years so precise? The key lies in the agreement across multiple lines of evidence. The cosmic microwave background provides a snapshot of the early universe, while the chemical composition of ancient stars reveals its timeline. Baryon acoustic oscillations give us a cosmic ruler, and the Hubble constant describes how fast the universe is expanding. This age estimate is also vital for understanding other cosmic phenomena, like the formation of the first galaxies and the development of large-scale structures. If the age of the universe were even slightly different, many of these processes would look drastically altered. The precise alignment of observational data shows not just the universe's age, but the reliability of the physical laws that govern its evolution. Each method, rooted in different areas of physics, independently arrives at the same result. This convergence is what gives scientists confidence. The story of the universe, from the Big Bang to the rise of stars and galaxies, is a cosmic timeline written in light, matter, and space, and 13.8 billion years marks the span of its incredible journey. As we explore the universe's 13.8 billion year story, it's impossible not to feel a sense of awe. This number is more than just a scientific measurement. It's a profound reminder of the vastness of time and the incredible journey of existence. Think about it. Every atom in your body, every molecule that makes up the air you breathe, was forged in the heart of a star billions of years ago. The universe isn't just a distant concept. It's our shared history, written across eons in light and matter. But here's the astonishing part. Within this incomprehensible span of time, we've carved out our tiny chapter. Humanity, with all its complexity, joy, and struggle, has emerged in the blink of a cosmic eye. Our ancestors walked the earth for mere tens of thousands of years, and our recorded history spans only a few millennia. Yet, in this brief moment, we've developed the tools to look back across time, to decode the universe's secrets, and to ask questions that transcend our own existence. The age of the universe also forces us to confront our place within it. We are, as Carl Sagan once said, a way for the cosmos to know itself. The same laws of physics that govern distant galaxies also govern the cells in our bodies. The same particles that make up stars and nebulae are the building blocks of our very being. This profound connection reveals something extraordinary. In understanding the universe, we are understanding ourselves. And yet, there's something humbling about this knowledge. In the grand scheme of 13.8 billion years, our lifespans are fleeting, our civilizations momentary. But rather than diminish our significance, this perspective makes every moment more precious. The vastness of time doesn't overshadow our existence, it amplifies it. Each moment we live, every act of kindness, creativity, or curiosity is a defiant spark of life in a cosmos that is mostly silent and empty. So, as we marvel at the universe's age, let us also marvel at the improbable miracle of being here to witness it. We're not just observers of this grand story, we're part of it. From the first light of the Big Bang to the light we create in our own lives, we are threads in the vast, intricate tapestry of existence. And that, perhaps, is the greatest mystery of all. That in a universe so ancient and immense, we have found the means to reflect, to wonder, and to dream. The universe is full of mysteries waiting to be explored. Which one do you want to uncover? Share your ideas in the comments and subscribe to the channel to keep joining this cosmic journey. See you next time.